Oh, hello, my dear friends. Welcome to a new video. Today we're going to solve the intersection of two linked lists problem on LeetCode. As an input, we will have two linked lists, and our goal is to find their intersection. For this example, we have a linked list A and a linked list B, and as you can see, they intersect in the node C1. So we need to return the node C1. Let's see the other examples. Here they have 8 as a shared node. Okay, but actually, as you can see here, well, 8, 4, and 5 are all shared elements between the two. We only need to return the head of the shared linked list, that is 8. Same thing here. 2 is the first element where the two linked lists intersect. So we're going to return 2. Here, the two linked lists have no elements shared. That means that we need to return null because there is no intersection. Cool. Now, how are we going to approach this problem? As I said in my previous videos, the first approach is better to be a brute force approach. And for the brute force approach, we just need to check all the equality of all the elements between the two lists. Okay? For example, I'm going to have a pointer here called PA and a pointer here called PB. Okay? After that, I'm going to compare PA and PB. PA and PB are not equal. Cool. So I'm going to increment my PB to the next element. PA and PB are not equal. Well, they have the same value, but not the same reference. They are different, okay? I should have taken another number to not confuse you, but anyways. Now, I'm going to increment again to the next element. Okay, it 6. So here my PB. 6 and 3 are different. Okay, I increment again. PB here. 7, 3 are different. Okay, so now, when I reach the end, I'm going to increment PA to the next element. And reset my PB to the beginning of my array. And I'm going to repeat the process until both PA and PB reach null, and that means that there is no intersection, or when I reach a situation where PA and PB are equal. And here, for my example, PA and PB will be joined here. And that means that we found an intersection and we need to return it. Now, in terms of time complexity, it would be O of n multiplied by m, with n is the length of the list A and m is the length of the list B, because we will have two nested loops. And the space complexity would be O of 1. This is the brute force approach. Let's translate that into code. As I said, we will need my first pointer called PA, initialized to head A. Then I need to make sure that my PA is different from null. Then I will need my second pointer called PB, initialized to head B. And again, another loop where I need to make sure that PB is different from null. And then I need to check if PA is equal to PB. That means that we found our intersection. Return PA. And if it's not the case, we increment our PB to its next element. And here, after we finish looping through all the list node B, we can increment our PA to its next element. And if we didn't find anything, we just return null. Let's run the code. Hopefully it works. Yes, it does. Let's submit it. Hopefully we don't have a time limit. We don't have a time limit. That's cool. But as you can see here, the runtime is 800 milliseconds. And that's actually a lot. Can we improve our solution? And the answer is yes. We are going to use a hash set. So the first thing we're going to do is storing all our nodes of our first list in our hash set. So I'm going to have a 3, I'm going to have a 1, I'm going to have a 2, I'm going to have a 3, 6, and a 7. Okay. First of all, I'm going to loop all through my elements here, the list node A, and put them in my hash set. So this is the first loop. The second loop, I'm going to loop through the second list node B, and at each element, I'm going to check if it already exists in the hash set. And to check if a key is contained in the hash set, the time complexity is O of 1. So that's really, really fast. Okay. So 5 doesn't exist here. 3, it does exist. It's this one. Not this one, okay? Not this one. It's this one, okay? Anyways, so yeah, 3 already exists in my hash set. Perfect. That means that we found our intersection. Now let's try, before going to the editor, let's see the time complexity. So first we will have O of n, because the first loop, and then O of m, the second loop in the worst case scenario. So basically it's O of n plus n, the time complexity, okay? And the space complexity would be O of, yeah, you guessed it, O of n, okay? So we were at O of 1, but now O of n. But we reduced from multiplication to just a sum. So it's simpler. So it's now linear. It's faster now, okay? Now let's try to write the code for the solution. So as I said, we will need a hash set of what? Of list nodes. And I'm going to call it C nodes. New hash set. And I will need a current that would be initialized to head A, and we will have our first while loop where the current must be not null, and we're gonna put in the C nodes our current, add current, and we can increment our current to the next element. Now we'll have our second while loop, but before that we need to reset our current to the head B, okay? While current is different from null, we need to check if C nodes contains our current. If it does exist, we return our current. And of course, we need to increment our current to the next element. And if you don't find anything, we just return null. Run code. It works. Submit the code. 10 milliseconds. It's much faster now. Okay, now can we find a better solution? Because we've done a compromise. We've made the program much faster, but now it takes much more memory. Can we have an algorithm with O of 1 time space complexity and still have O of n plus m time complexity? And the answer is yes. Oops. Now let's try, let me explain you the last solution. Before that, just let me draw some lists. So imagine we are in this situation. We have 2 list nodes. One is longer than the other. So the size of A is n, and the size of B is m. Okay. So basically, the only nodes that could be an intersection would be these nodes. This one. It's either these ones, or these ones, or these ones. Okay. And basically, if imagine with me, if we had a pointer pointing to this node, and another pointer, I'm gonna call it PA, and another pointer called PB pointing to this. Imagine we are in this situation. We have PA and PB pointing to these elements. So what we need to do then is just compare the 2 pointers and increment them at each point. And at every iteration, we need to compare them, obviously. And if we find them at some point they are equal, that means that we found our intersection. But you're going to ask me, how are we going to get these pointers pointing to these nodes? I'm going to show you how. I'm going to draw again a new linked list here. And then we're going to have a pointer here, PA, at the beginning, and then another pointer, PB, at the beginning. We're going to increment them until they reach, one of them reach the end. So this one will reach the end first because it's the smaller one, and this one will reach this element. Oops, removed this one. Now at this situation, when the PA is at the end, in the next iteration, it's going to go to null, the null value. We can actually allow that. So PA is going to be here, and PB is going to be here. But now in the next iteration again, we're going to check, oh, PA is null. Now PA will go to the beginning of PB. PA will be here. And PB in the next iteration will go to null, to the null pointer. So PB will be here. Now in the next iteration, PA would be here, and PB, like PA, will go to the other, this node. Oh, does it look familiar? Yes, it does. We have now the same situation as this. And now what we could do is just try to compare PA and PB until we find the correct intersection. So the trick is really simple. You just need to have a pointer, 2 pointers pointing at the beginning of each list, and then increment them until they reach the end. When they reach the null value, you need to swap that pointer and put it into the beginning of the other list, and do the same thing for the other pointer. Yes, this is a really tricky, really good trick to use and to have in the belt. Now let's try to code that. Okay, so first thing, and we need 2 pointers, this node PA hit A, and this node PB hit B. And I need to make sure I need to loop until PA is equal to PB. And I can return PA, either one of them, okay? Either they both are equal to null, that means that there is no intersection, or if they are equal, we're gonna return one of them. Then PA is going to equal, we need to check if PA is null. As I said, it needs to be reset to the head of the other list. And if it's not the case, we just put the PA dot next. And we invert for the other head. Okay. PB, PB, PB. Okay, it looks good to me. Run the code. Yeah, it works. Submit the code. 3 milliseconds. Perfect. So it works. So the time complexity for this one is O of n plus m, and the space complexity is O of 1. Great. That's a much better solution. So this is it. Thank you for watching. See you in the next video. Bye.